This is continuation of our networking layer module. Technically, it's not exactly IPv4, but it's a fundamental part of IPv4 or like IP router. And specifically, we're going to be talking here about network configuration, and one of the protocols that are being used for network configuration is DHCP. So first of all, network configuration. So in order for the host to, like IP host, to be actually part of the network, it needs to have several configurations. Depending on what we're configuring, whether it's an end system or whether it's router, it would have slight differences in how things are being operated. But in general, there are a few parameters. So as a basic thing, you would have to have IP addresses. And if you have interface that needs to run IP protocol, this interface have to have IP address, at the very least one. To give you a little bit more, each interface can have more than one IP address. This is in IPv6, that's the norm. In IPv4, it's not really the norm, but you can have multiple IP addresses as well, and you can configure them on most systems. I think on phones, it's a little bit hard to configure multiple IP addresses, but it's technically possible. So if you have interface, you have at least one IP address, you can have more. You have two interfaces, you have two IP addresses. For each of when you configure IP addresses, you don't really configure just IP address. You have to specify subnetwork. And as we're going to be talking later, this will specifically for the purpose of configuring local routing table. So to decide what this address, which network this address belong, and whether kind of something that you send into this subnetwork can be reached directly, or you have to go through the gateway. So basically, that's the decision. Like the mask and IP address decides through the routing table, through the help of the routing table, whether something can be reached directly, so you can just send packet to that subnetwork, or you have to send the packet through the gateway. That's it. Then for the end host configuration, you have to specify default gateway. So basically, again, this is some form of routing table configuration. And the other one that we already talked before is a DNS caching resolver, because most of our applications are dealing with the DNS names instead of just IP addresses. We have to have a mechanism to resolve. And this is the information we usually have to configure either manually or automatically. All of this information can be configured statically, like can be manually configured, be it on Windows, Unix, Mac, or even on iPhone, Android phones. So you just go to the network settings and you set up all those parameters. You can do it manually, but usually this process is not done manually. So this one usually done using for the for IPv4, it's usually done using DHCP protocol, although you can see what's written. It's a dynamic host configuration protocol. And basically what the DHCP is doing is some form of a protocol that I will highlight in a few more slides that gives you information that you need. Like you wake up, you just turn on the interface and you send a few requests saying, oh, I'm alone here, anybody tell me what I need to configure, and the DHCP server is saying, oh, here's information, and kind of now you get the information and you now can communicate globally effectively. There is one more thing. Again, this would not allow you to communicate globally, but in any case, if you didn't get a manually configured IP address, and if you didn't get configured through the DHCP, there is still address that will be assigned to you by the kind of compliant IP stack. It will be link local address. You may or may not saw this IP address before, but for example, if you connected to some Ethernet or Wi-Fi network that's somehow broken or misconfigured, after a minute or so, you will get some address from 169 to 54 range. So this one is simply IP address that can be used to communicate locally within this link, but not technically kind of designed to be for conversations beyond just this specific link. But getting back to the DHCP. As I said, the DHCP is about kind of this automatic process of someone waking up, or like setting up the interface and trying to communicate, but technically it's actually a 4-step process. There are a few more things that in addition to this process, but I'm just highlighting this 4. So basically what's the process is contains discovery, offer, request, and act, and this is from different perspectives. So what discover is? So discover is I'm waking up and I'm just basically sending SOS message saying, oh, I'm alone. I have nobody around me. Oh, at least I don't know about anybody around me. Someone tell me what I can configure. Then any DHCP server and the network doesn't have to have just one DHCP server. So each network can have 0 to multiple DHCP servers. Hopefully, if you have multiple, then they're providing you the same information. They know about each other. But there are misconfigured networks where there's 2 DHCP servers that have a conflicting information, and depending on the luck, effectively, you will take information from different. So basically, the offer is DHCP server receiving this SOS message from the client and saying, oh, here, like I have these resources, you can try to use this one. And if you have multiple servers available, so you simply can receive multiple offers. And then it's back to the requester decision. And the requester can simply look at these offers. I don't know, I usually, they don't evaluate, just pick one that arrives first, but technically there can be policy to evaluate different offers, and it can pick one of those offers and say, okay, I like this specific offer, I'm acknowledging that I'm using it. And basically, not acknowledging, so I'm requesting to use the addresses from this offer. So this is like a DHCP request. And finally, if server's offer is still valid and the server receives this request, it's simply responding with the acknowledgement. Okay, so yeah, now use your resources and go on. So this is the basic process. A few more details to this process is which IP address is being used as part of the communication. I think I highlighted in part 2 that there is this special IP address 255.255.255 saying that everybody, like broadcast to anybody who can hear this. So basically, you send this to this destination. As a source, you don't have IP addresses, so it specifies 0000. And this doesn't really matter. And there is some information, kind of what you asking and so forth. Afterwards, you hopefully gonna get one or more DHCP offers. So DHCP offer will have source IP address of that DHCP server, but it's still gonna be sending this packet or like offer to 255 address. And I mean, I can give you the reason, because source still doesn't have IP address, so you cannot really send to the host that doesn't have IP address. So basically, the client doesn't have a IP address, so the server have to send this offer to everybody. Finally, the requester trying to send request to request that IP address that being offered. So this one is actually a little bit tricky. So they still use the destination IP address as 255.255. However, it technically could have used the IP address of the server. It doesn't use it, but it could have. And on the flip side, it's the server replies with a DHCP acknowledgement saying that, oh, please use it, and it's still being sent out to broadcast address. And to highlight why you may need to use this request and acknowledgement in the broadcast address is to make sure that other servers see those requests and see the acknowledgements. So basically, when initially client requested the IP address, it received multiple offers. So, and everybody who observing this network, basically all DHCP servers, they will see those requests. They will see those offers. And as soon as the client requests a specific offer, they immediately will see that, the client actually didn't pick ours, bad client. So they may already kind of release those resources, or may they keep them temporarily, but with a smaller timeout, expecting one of the DHCP servers would acknowledge those resources. And as soon as they see those acknowledgements, they basically release resources because they already see that the client has picked a specific offer and it wasn't theirs. So basically, that's the whole process: discover, offer, request, and acknowledgement. One thing that I would like to note about DHCP is all the resources being given to you at kind of temporarily. And if you open the network preferences in all systems, you most likely will see word lease or like renew the lease or some kind of a renew. And this simply reflects the concept of temporariness of DHCP address or DHCP configuration, because DHCP does give you more than just IP address. And basically, it really depends on the configuration of the system. Sometimes the system is configured to give you the same IP address always, like it may even look at the MAC address of your network interface and then always give you the same IP address, or it can give you kind of IP address for this hour, and the next hour when you try to renew, there is also renew process. If you try to renew IP address, it may give you the same IP address or may give you some different network configuration. So it really depends on the specific settings. Okay, so that's a basic all about the network configuration of the host and kind of router. Remember that you still need at least one IP address and subnet per interface. You may have more, but at least one is necessary. On a system, again, depending on the specific system, but if you're talking about host system, you will need the default gateway. You will need the DNS cache resolver, and you may need additional parameters. So sometimes there's I think the other one is a DNS search list. Again, it's not that popular, not used too much. So that's kind of the configuration needed, and you can get this configuration either manually from DHCP or kind of don't get it, and then you will be assigned only automatically link local address. And finally, with DHCP, it automates network configuration. It can give you you can have multiple servers available, and it will give you information in network configuration that is temporary. Okay, so that's it for this small part, and see you later.